Is my screen visible to all?
Hello. Hello, am I audible?
Yes, yes, yeah.
Thanks.
Okay. So I hope my screen is visible to all. So today I will continue from where we left off yesterday. We were quickly seeing server, client, and some UI side testing and all those things. So we'll be continuing from there. Let me just change my audio. Is my voice audible to all?
For me, yes.
Okay, yeah. So anyone has any queries from yesterday's session? Anything you want me to quickly revisit?
Yesterday I missed first 15 minutes of session. That's
Okay.
fine. That's fine. But still, just give me an overview, just a few highlight points that what we have covered yesterday, and we will continue today, please.
Yeah, yeah, got it. So first 15 minutes, I guess what we were seeing is on the client server. So we were seeing if you have any architecture, you can sorry, you can just in a nutshell, you can write client server, where client means your mobile app or your website browser, your kiosk machine, anything can be your client. Okay. Similarly, server is where my code is sitting, and or where the processing of the code etc is happening. That is my server. Okay. So now here I can even have JMeter also as a client. So when we run a performance test, JMeter is your client. Okay. So this way you can just show a architecture in a simple way, and client sends a request and receives a response. Okay, so that's what the request and response we have. So server will send the response, client will request to the server. Okay, so we will see all this today. Okay, now there are various types of architecture available: one tier, two tier, three tier, and distributed systems. These are some architectural, we can say, tiers. Okay, now, if I have in the modern period or in this modern generation, generally we don't have one tier and all. We only have three tier and maybe two tier, but not one tier. It doesn't exist anymore. We will discuss all those. So, if I try to draw a modern architecture, how it will look like is, so before we go, so there were one tier architecture, two tier, and three tier. Now, can someone give me an example of one tier architecture? Anyone? Anyone heard about one tier architecture before? So, what I can call it as a one tier architecture?
Can I say desktop application?
Okay. Anything else?
Sir, all the three server activities like application, database, and presentation, all these three activities done by one single
Mhm.
unit.
Yes. So let's see one by one. So, for example, let's say now to understand this one tier, two tier, and three tier, what I will do now, we will just take an example of let's say you have let's speak about the one tier. Okay. Let's say we have a street food cart, like let's say some stall, a food stall. Okay. So the chef, the menu, the ingredients, and the service, everything is in one place. which is inside that food truck or whatever. Okay, it's all in the one place. Okay, so customer directly asks the vendor, he prepares the food right there and serves it. So let's say a food truck, I'm saying. Okay, a food truck. So everything is happening inside that food truck itself. Okay, so this is an example of one tier. So here in software, if you compare the same thing, it will be like, let's say you have the UI, the business logic and data are all bundled together in one system. So UI plus business logic plus data all are in one single system. Okay, so and this type of application we call one tier. And exactly as someone said, desktop application, right? A desktop application is an example of a one tier architecture. So with its own built-in database and all, like if someone remembers like MS Access apps and all, no, they have their own built-in DBs and all. Little old, okay, but you can say desktop app is a one tier architecture example. Now, if I go to two tier, so what happened with the two tier? No, again, imagine a small restaurant where you have the front area where you, as you enter the restaurant, and you have the kitchen. So front area and kitchen. So in the front area, you have the waiter, menu, and all those. Okay, kitchen is where the chef and pantry, all the things are there. So in our case, this front area we call it the client, and kitchen we call the server. So this way customers will, so what happens, customer will place the order in front area, and things will go to the kitchen, it will get cooked, again it will come to so in the kitchen what will happen, it will cook it, it will take the ingredients, store it, and everything, storing the ingredient, everything will happen in the kitchen. Okay, so and it will come back and the customer will get it. Same way in our software architecture, what will happen, our we will give some request, client will take the request, send it to the server, server will process it and give it back to the client. So what happens here is UI is on the client side, the server will handle the business logic and the DB both. Okay, so this way we, when we have two, one and two, this is one, this is two, we have two tier architecture. Now the example is client server apps like any banking system. So where a client program will directly talk to a DB server and all. So in those situations, we have a client server app. Okay. So like where, as I said, so in that system, what will happen is the client program will talk to a DB server. So DB server is basically where the data is stored and all. No, but the app will be, let's say, on their system, maybe in their internal system only. It won't be available to everyone and all, but it will speak to a specific database server and give the data back. Okay, such sort of setup you will find in the two tier. Now this one tier, two tier architecture is almost obsolete now. Okay, so now most of the applications we have three tier and plus. Okay, so what happens in three tier again? Let's say there's a 5-star hotel. Okay, now in the 5-star hotel, what happens? Waiters and, let's say, menu is what your customer will see. Customer sees. So I can say this is my presentation layer. I call it presentation layer. Okay. Then second, I have chef in the kitchen. Okay, where the cooking will happen, right? So chefs in the kitchen where the cooking will happen. And I can call it like application layer. then pantry or the warehouse. Here is where all the ingredients are stored. And this place, we can call it database layer. So what happens here? So here the chefs will not go to the warehouse every time. Instead, they will follow a process. For example, waiter will take the order, and chef will decide how to cook the ingredients. Now, based on now, can I ask you this question? Will chef go to pantry always, or only when it is required?
When it is required.
When it is required. So same thing will happen. So when my application, when some request will come, it will go to application layer, and application layer, if required, it will go to the DB layer. Not, it's optional one. It will go only if it is required. So if, let's say, I am logging in, I am putting username and password. What do you think? Will it go to the DB?
No.
Directly no.
Like, so where it will check the username password combination?
No, it is directly it went to DB.
Yes, exactly, right. It will access the DB because the username password combination is stored in the DB. It has to access the DB, to check whether that person can log in or not. But let's say I am pulling, for example, I am just directly pulling one image, some ax.jpg. Will it go to DB?
That is not required. Actually, that is only for presentation layer, right? So it will
Correct.
not
So,
go.
so this image is just in a path that image is there. It will just pull that image. That's all. Nothing related to DB. No, in DB data is stored. Nothing related to data here. It's an image. So wherever data is needed, only there the DB will be called. Otherwise, it won't be called. Right. So same thing happens here. So in the three-tier architecture, we have a presentation layer from where the request goes, then the application layer where the request is processed and all, then the DB layer where the database server, if the data is needed, it will pick the data from there and send it. So this is a three-tier architecture setup. Now, generally, in most of the applications, we follow such a setup. Okay, for example, when I say presentation layer, I can say UI. Okay, which is equal to, let's say, browser or your mobile app. Okay, then let's say application layer. Application layer is my business logic. Business logic means server that processes the rules and all, I can say. Or I can say the code, right, basically. Then I have the data layer, where I have the DB. So, where the data is stored and processed. Okay. So, this is example is like Amazon, Flipkart, all the modern web apps work in this way. Okay. So, generally, they are all three-tier architecture, we can say. Okay. So yeah, so that's how now this analogy you can take it to entire architecture also, which we call it multi-tier or microservices and all, right? That we will see. Now after three-tier comes more layers. So what we do is simple. Presentation layer, if it almost remains same, but whatever comes below that, right? We separate it into multiple layers, okay, so that each layer will go beyond based on what's required. Not always everything is needed, no, so we keep creating hierarchy, right, layers, so that our system becomes faster, and that's where the microservices concepts also come in, and Kubernetes. Okay, we will see that when we go to those sections. Okay, right, so that's a three-tier architecture. Now in a modern uh, physical diagram, okay, if I draw a general cloud, let's say an application is there on cloud, okay, and if I draw the diagram, an architecture diagram for that, how the diagram will look like, okay, a general one this is. Okay, so first you have your, I can say client. Okay, I'll give the name client. So this can be mobile app, your browser, kiosk machine, anything. Okay, from where you're sending the request. Then now what I will do, I will start from the back side. Okay, from the most fundamental thing. So let's say I have the DB server. Then I have the web/app server. Then I have the wait, we can put one more thing before this. Then I have my load balancer server. Then I have my middleware. Then I have my CDN. And now the same thing. Okay, so this is a high level diagram or an architectural diagram of a general application that you see online, like Amazon, Flipkart, and all. Okay,
Just
now,
one quick question over here.
yeah,
So it is it a on-prem application or it's a cloud or it's for both?
yes, it's for both. Okay, I'll explain that next, but that's what we are going to see. Okay, so now let's say my application is on cloud. Okay, so what will happen on cloud? No, starting from here, it will be all on AWS. So when I say all on AWS, see wherever you're seeing the server, no, what do you think they are? Physically, what they are?
Physical machines
Yes, exactly,
actually.
right? They are systems. So they are a combination of CPU, RAM, disk. They are systems, right? Now, when I say system, it can be more than one. It can be 1, 2, 3, 4. Let's say my load balancer is a very heavy load balancer. It needs more power to do what it is doing. It might need 4 or 5 systems. Similarly, my web server, it handles a lot of users. So it might not be of one system. It might be of 15, 20 CPUs combination systems. DB, if my DB is doing a lot of operations, it cannot do it in one CPU. It might have more than one, right? So that way things will. But now, so let's say this is 5 system, 20 system, DB is 5 system, total 30 systems. Now all this 30 system will be on the AWS, and AWS, if you know, it has EC2, right? For example, I'm saying, okay, EC2 is whenever you are using AWS, the computational power or the systems that you get from AWS, we call it EC2. Okay, and similarly in Azure we have VM. In Google we have cloud, we have compute engine. Okay, different names, but all are basically systems or CPUs you are giving. So that also we will discuss soon. Okay, now this same thing, if I am managing, I'm like if I'm not doing it on cloud. I have bought it. All these 30 CPUs I have bought it and I've set it up. We call it on premise, right? So this whole system here, right? Actually, this is the system, we call it the backend. And this we call it the front end. These are basically optional services. Okay, it's not always needed. They are needed to improve performance, security. Okay, for those reasons we have middleware and CDN. Generally, both of them are optional. It's not that all the application will have CDN and middleware. Load balancer, most of the applications will have it, especially if there is a heavy load. Okay, so that's how you can divide a front end and a back end. Okay, now let me, before I go deeper into this CDN, middleware, load balancer, servers, and all these things, okay, let me explain the difference between some basic difference between this cloud, on-premise, and all those. Okay. So when we say an application is on cloud or on-premise, okay, let's try to understand that. So let's say I have a home here, and I have my Airtel Wi-Fi, and I'm very bad at drawing, but I have my power connection 24/7. And let's say inside my home, if I draw it in some 3D figure, I have, let's say, a system also. Okay. And the system is, let's say, some 36, some 128 GB RAM, 10 TB SSD, and let's say some 16 core CPU. So I have that system also. Okay. Now what I will do, so can I, let's say I want to run Vishnu.com, and I have written an HTML code. Okay, HTML code for that application, for that website. Now, can I run this Vishnu.com in this CPU here? Can I run that? So that anyone, Tirupati or Sharjun or anyone can access Vishnu.com from their homes. Can I do that?
Directly you can't, I think, man.
If it's not hosted over any server, then
So this
No.
is
So my
.com, right?
question
We
is,
can.
can I make this? Can I make this CPU my server?
We
Ah,
can, right?
yes,
Yeah.
We
yes,
can.
yes.
Exactly, right?
yes.
We
So
can.
very simple. So my application I have put in my server. I mean, like basically my CPU. So when I'm doing this, we call it hosting. Okay, I'm hosting my website Vishnu.com in my CPU, and when I'm hosting it in my own home or own place, we call it on-premise. So now instead of this home, what I will do? I will draw a, let's say, a bigger office which has
Yes.
100 CPUs like that. So now this one will become for, let's say, a business like Amazon and all, right? Amazon.com. So so they cannot run it with just one server, no? They need a lot of energy or power. Sorry, system to run their application. So they will set up a whole 100 CPU network. Again, power, Wi-Fi, all these connections will be provided 24/7 without any hindrance, and it will run. My question to all of you is, if my Wi-Fi goes, will my Vishnu.com be accessible?
No.
No.
No, right? So it has to be always connected to the internet or network. Then only I will be able to access Vishnu.com through the server that I have installed. Okay. So that is one thing. So same thing happens here also. So they have to maintain the power, they have to maintain the Wi-Fi. So there is a lot of maintenance here when you have on-premise, when you are managing your own thing. Okay. So what people thought, why can't I start a business where this whole thing I will rent out? So when I say rent out, so I build a, a building full of, like, let's say 1,000 CPUs. I set the power, I set the Wi-Fi network needed, and proper backup and all those things I do. Okay. And then what I do, I'll say to Tirupati, you need 10 CPUs. You can buy it from me per month. You can pay 1,000 rupees. Similarly, so it's given to Tirupati. Sharjun, let's say he needs 100 CPU to run his application. I say you can pay me 10,000 rupees per month. So similar, but for 1,000 CPUs, let's say I spent 10 lakhs. Okay, so I have did some investment and I'm renting it out to multiple people. Okay, so what they will do? So why is Tirupati buying this CPU from me? Why is he buying? For what purpose?
He wants to host his website.
Correct, right? He wants to host Tirupati.com. Oh, Tirupati.com might be there already, right? So, okay, he wants to host his own website, maybe, yeah, Tirupati. Okay. So, when you type Tirupati.com, maybe the real Tirupati will come. So, it's already there. Okay. Then next, Sharjun, he will host his own, like let's say Sharjun.com, right? So, they are hosting their own application based on their need. They are buying it from me, and they are paying me a rent, monthly rent or whatever. And this concept, right, when we scale it, we call it cloud. Simple. Are you all clear till here? So
Yes.
what is AWS? AWS is nothing. AWS invested crores of rupees and brought, like let's say 1 lakh CPUs, or we never say CPUs or systems, we say servers, okay, directly, because they are used for hosting websites, nothing else, right? So directly they call it servers. So they buy some, they set up a server, like say 1 lakh servers in a place, and they call that place called server farm. And from there, people can rent out those servers for their application needs, and they gave it AWS. Now, what happened is, what they found is, now let's say I started renting business. Okay, I'm renting a home. So what I do, I buy flats and I rent it. Now, what I felt is, if I want to increase my profit with the available flats, let's say I have 10 flats, I'm renting those flats. Okay, what I did, I thought, okay, let me add renting furniture also, because obviously who will be renting my flat, they might need furniture renting also. So I start renting furniture. Then let's say afterwards I thought, okay, with furniture renting, I will give some extra service, like let's say cook. So with the cook, what will happen, I can get some extra rent and make some extra money. So same thing happened with cloud also. So cloud, they started with simple CPUs sort of arrangement. They gave servers, but with that they also added some other services like an add-on. For example, in AWS you have SNS, notification service, SQS, queuing service. Then you have DynamoDB, their own proprietary DB they call it, which is a non-relational DB. Then they have other services like Lambda and many lots of other services. Okay, if I speak about AI, they have BlackRock, AWS BlackRock. Okay, it's an AI service by AWS. So people who use AWS, they thought, okay, let's use SNS, SQS, DynamoDB, and all for their application. And all of this is actually paid, an add-on value. Also, sometimes you get, when you buy something, you get something free. That also they did, like a promotion and all, right? So that's how the cloud became evolved with a lot of different services. That's what you are seeing now. When you say AWS, Google Cloud, and all, right? And Kubernetes and all is one part of that. Okay, what happened? So yeah. So till now, any questions, anyone? What is
Yeah,
on-premise and what is cloud?
I have
Yeah,
one question.
yeah.
What is the difference of the approach for conducting performance test for from on-prem application?
Mhm. So let's say I
The
have a
diff-
client, okay,
yeah.
and I have server. When I'm running performance test, what I am as a performance tester, I am seeing client or server. What am I seeing?
Server.
Client,
So in my hand, what is there? JMeter, and
client.
JMeter
Client.
is actually a
Mm.
client.
Line.
right? So whether it's on cloud, whether it's on premise, my JMeter script will not change. It will be same,
Correct.
right? But what will change is the monitoring and analysis. Because what will happen is if my server is on cloud, I will have to monitor it in that way. Because let's say AWS monitoring is different from on-premise monitoring, right? So
AWS Azure Cloud, correct?
no, AWS is Amazon Web Services.
Amazon, sorry. Yeah,
Yeah.
okay.
Azure is different. Azure is of Microsoft. Okay. Then we have Google Cloud, which is of Google. So this way, three are the major ones. Then we have Oracle Cloud nowadays getting good popularity due to AI and all. Then there is even Alibaba Cloud also. Some other clouds like that, very niche clouds. Okay, but these three are the major players.
For Azure, I'm aware that we do have App Insight
Hmm.
for monitoring purpose.
It doesn't matter whether that tool you use. You can install AppDynamics in all three, no?
Okay.
But only thing is, see, what I'm trying to say here is now SNS is there only in AWS. We don't have it in Azure. Okay.
SMS.
SNS, Service Notification System. Okay. So
Okay.
that is a proprietary tool by AWS. So monitoring SNS you can do only in AWS, no? You cannot do it
Okay.
everywhere
Yeah.
because it will be there only in SNS. Similarly, Azure has their own but different notification service. Okay. So what I'm trying to say is based on what's there in the back end, your monitoring tool setup and all those things will change. Okay. So, but as
Okay.
a JMeter is concerned, nothing will change as a performance tester. But as a monitoring and analysis is concerned, things will change.
And what is that Lambda and all? These are the
Those are
services.
this. Yeah, those are like this auto scaling and all is controlled by Lambda. It's a service. Yeah.
It's a service for auto scaling.
Not only auto scaling, various different automations of your system. Yeah.
So actually, this question has been asked to me
Mm-hmm.
that what is the difference in approach for testing or doing conducting performance test over cloud applications
Mm-hmm.
than on-prem application, and till today I'm actually not aware of it.
Yeah, because that is a very open-ended question. You have to ask them more follow-up questions, right? Because when they ask you this, you
Hmm.
can say a whole Ramayana, 10 hours. Okay, because there's a lot of things you can discuss on that. But the thing is now, if you have to narrow it down. You have to come to how I monitor and analyze the system. That will change. But how do I make the script? Both it will be same
It
only
will be
because
same, correct?
yeah, because both are HTTP protocols
Yep.
only.
Yep.
Okay, so it doesn't matter whether it's backend is cloud, Java, Go programming, on premise, nothing. Our protocol is HTTP, things will be same in
But
JMeter side.
in
But
it's
what will change is in the monitoring. For example, let's say if I have microservices. In microservices, I will get three graphs. In if I don't have microservices, I will get only one graph. Now, how
okay.
is it? So in microservices front end, catalog, order, all three will be different. Here, all three will be in the same graph only. If it is on premise.
In
No,
microservices,
sorry,
you
not
suggested
on
there will be
premise,
three
distributed
graphs.
systems. Sorry, yeah.
For microservices, you suggested what all three graphs you specified?
No, this is an example I give. These are the microservices names I am saying.
Okay.
Okay, but in monolithic systems we don't have microservice, so everything will be in a single graph, the CPU, because all the services will use a single CPU. But here everything is isolated. So yeah, when we go to those topics, we will learn that. Okay, this is little
Okay.
high jump now.
Okay.
Yeah.
So very simple way, what is the on-prem actually?
On-prem, yeah, we haven't finished that. We are still there only, okay? We are seeing now we have reached cloud. We will soon come to a conclusion. What basically an on-prem is. So simple. On-prem means you manage your server. So you buy the CPU, right? Like say you are you buy 10 CPUs, 20 CPUs, whatever is needed, and you set up the server, you host your application. So you manage your server. But in cloud, they manage your server. You just put your code and other things onto that server. So that is cloud in a simple way. Now, why do we choose between on-prem and cloud? That is very important question, no? Can someone say why? Like how do I choose whether I should go for with on-prem or cloud?
It's for cost optimization. Basically, we want to reduce our costs. So
So here initial cost is very high. Here initial cost is very low because here you pay like monthly, hourly, okay? But here you pay, you have to buy all the things at once, right? Whatever is needed. So initial cost is very high with on-premise. On cloud, you're paying per hour, per month and all. So you're not paying. So for example, let's say I'm buying 10 CPUs, it will cost me, let's say 10 lakhs. Now the same thing, if I'm paying it in installments, it will be less. So same happens in the cloud. It is less costly, okay, when I buy it in cloud. Now, but the main problem, you might think, okay, cloud is really good because cost is low. How much ever system I want, I can get on cloud. There's no limitation. So when I say that, how much ever systems means, let's say here I bought 10 CPUs. Now suddenly, due to some reason, I need 15, which is difficult to set up quickly, right? But in cloud, I can get it very easily, 15, right? Fast, or 20, 30. I can bring it down to 10, 5, 2 also again. So I don't need to pay always for 15, 10, 20. I can pay sometimes for 2, 3, whatever is needed, right? So that sort of flexibility I have in cloud. But can someone say what is the main problem? One important problem that we
Maintenance.
no, what I'm trying to say is why where on-premise wins.
so I over the time that cloud becomes expensive and on-premises.
No, I feel the accessibility of on-prem servers.
Mm, uh, mm, Go deeper, little bit more. Fundamental thing.
So I think for security,
Security.
also you have your own data on.
It's
You can
not
Exactly,
shared.
right? So your data, right? That is very important, no?
Mm.
When you have cloud, the data is on AWS. So let's say your user data. You are a very big company, like let's say McDonald's. Okay. Now, if McDonald's keeps their data on AWS, like their user data and all, who knows? Maybe Amazon might use it. No, they do. Though they say SLA agreement, privacy, and all those things, that data is on their system. Maybe they might tamper it, or they might see it, or whatever, right? So that sort of, and also if something goes wrong and if that data gets deleted, you may give the case and all whatever you want to do, but the data is gone, right? So data, right, that data security, data reliability, all these things will affect when you go on cloud. So whichever systems need data, like mission critical data, no, which is there, in those situations you go with on premise. Other cases you go with on cloud. So that's why what people will do, they follow an hybrid approach. So whichever applications, like for example, let's say so what they do, they will divide the customer application and the front end, let's say other applications different. So all the customer data will get stored in on premise, and whatever, let's say the burger photos and all those catalog and all those things will be on cloud, right? So that way they will divide the whole application. So they will divide into not critical data, whatever is there, they will create a different application and put it in on premise, and whatever is non critical, they will put it on cloud, a different application, and both will interact with each other using APIs. Okay, so that's how the hybrid architecture will work. So most of the applications nowadays are hybrid. They have little on-premise, they have more, little, I can say more cloud. But on-premise will mainly handle the data critical systems. So especially banking and all also, they will be mostly on-premise because they cannot look for saving cost. They have to worry about the data. Okay, so banking applications generally you will find on-premise only, not on cloud.
Sir, are we going to cover the monitoring and analysis of any application which is on cloud
Yes, yes.
in this
So we
course?
will see one example. Let me do one thing. I will show quickly one small example of a cloud system. Give me a moment. Let me log into Azure. Okay, I have an Azure account. Let me log into that. I actually have all three, AWS, Azure, and Google Cloud also, but I will show with Azure because Azure is getting popular nowadays.
As you suggested, Vishnu, that we if AppDynamics, Dynatrace, or Splunk, so we need to ask specifically to client to get these tools for monitoring purpose. Correct?
Correct. Yes. Otherwise, Grafana, the open source tools you have to set up.
Okay, these are the AppDynamics, and these other tools are like paid one.
Paid. Yes.
Okay, and Grafana is free.
Open source. Yeah. Kibana
Okay,
is open source. There are many other open source things like
okay.
that. Okay. So now if you see here, this is an Azure cloud system. I'm sharing my screen again. Able to see my screen now? Again?
Yeah,
Yes.
yeah.
Yes, Vishnu.
Okay. So now I am inside Azure. Okay. So here, if you see, now I have a virtual machine created. So how do I create? I can easily create it if I just type virtual here. You will get this virtual machine. So virtual machines are for Azure EC2. In AWS we have EC2. In Azure we have virtual machines. So if I click on virtual machines, I can add new virtual machines. For example, these are all the virtual machines which I have now here. Okay. So what I'll do is I'll create a virtual machine. Let's say if I click on virtual machine, first of all, I have to choose the because it's a paid one, right? It will ask for the cost, which resource group, and some technicalities of Azure. No need to go with that. But ultimately, I can choose what type of machine. So I can see all sizes, right? If I go here, I can clearly see what is the cost of each machines. If you see, let's say this is one machine B4 ASV2, it is costing 5,976 rupees per month. Okay, but we don't pay per month. Actually, it is per hour cost. So, but it is showing per month here. That's all for your calculation, easy calculation. So similarly, various machines. So based on how much RAM you need, how much V cores you need, what data disk, what max IOPS you need, some technicalities again. You will your cost will change. For example, if I go here, so this is 4 core, 16 GB RAM, 8 data disk, but the cost is 12,000. But same thing if you see here, 4, 16, 8, this combination, it is 6,000. Can someone say why it could be happening? Because CPU is same, RAM is same, disk is almost same, IOPS is almost same for both this and this, but cost is double. What could be the reason? Any guess?
Any operating system or something?
See now, in the CPUs also there are various CPUs, no, i3, i4, i7,
Hmm.
and also there is AMD, Intel. So what type of machine that is, that also matters a lot. Generally, Intels are costly than AMD, right? Similarly, generations, right? Lower generation is less costly. Higher generations are costly, though the cores might be same, right?
Mm-hmm.
So that sort of differences will happen. So if I want to read more about this machine, just copy it, copy the name, just type go online, paste it, you will get this. And if you scroll down, you can see it is Intel Xeon Platinum 8473C is the CPU that machine is using. Okay. Similarly, other features and all you'll be able to see. Okay, the based on the version and all. So that's how
And
you get more
just
details about that machine.
a
Yeah,
very good point I get to know, just as you shown this thing. If
yeah.
we do have a subscription name available, can we get these details just by subscription name as well for Azure?
So what do you mean subscription name? I didn't get that. So this subscription you're talking about what I showed before?
uh, that I'm actually not aware. So, see, if for a
Hmm.
customer, if they are buying some services from the Azure,
Uh-huh.
okay, so Azure must be providing some kind of subscription to the customer, correct?
Correct. Yes.
So if we do have only subscription name available,
Hmm.
that is what actually I'm struggling with at the moment. I do have
Okay.
the subscription name, but I really don't know what is the capacity behind that particular subscription.
Yeah. So see what happened. Now the subscription means this is where from where your money will go. Okay. So
Hmm.
whatever you buy, everything will go through this subscription. Okay. So,
Yeah.
but with just the name, you won't get access to what all they have bought and all. Okay. You need access to this subscription, maybe a view, a read-only access, or some access level you need. Then only you can. With just name, you cannot.
With name. Okay. Okay.
Yeah.
Yeah.
Okay. So yeah, again, there are some concepts like region, availability zones, and all that I'll explain soon. Okay, what they are. So yeah, so ultimately, all of you are getting the point that cloud also is a system only, nothing great. They have a CPU sitting somewhere, and we are accessing it remotely. Is that part clear to all?
Yeah.
Yeah,
So
clear.
let's say I chose a system. Again, I have to choose operating system also, no? Because a system won't work without an operating system. So this is where that image comes into picture, whether it's Ubuntu, Windows, or what I need to use. Again, if I use Windows, it becomes costly because it's a paid operating system. If I use Ubuntu, it is a open source. So the cost comes down of the server. So can you all guess? Most of the servers in this world will be Ubuntu or Windows?
Ubuntu.
Window.
Ubuntu. I'm
Ubuntu.
basically Linux, okay? Linux based because the cost of the Linux based servers are very less.
Sir,
Yeah,
these are the features we are selecting for client machines. No?
sorry, repeat,
I
repeat.
mean, Azure is these are the features we are selecting for client machines, right?
For server. So
Azure
once
is
I
one
create
server.
this machine,
Mhm.
yeah. So now, no, now this will become like a machine. Now inside that machine, I will put my code and all, and I will run it.
Okay, so these are the feature of server machine.
Correct. Yes.
Okay.
Okay. So simple. Now I have my laptop. I install Chrome in my laptop, and then I am able to access Chrome. Right. Same way, this machine I will create. Now in that machine, I can install any applications, or I can put my code and run. I can host my application inside that server.
Okay.
Okay. Yeah. So just I'm showing how the Azure servers works. Okay. That's why I showed this.
But it's not a performance tester or engineer
No, no, no,
that
no.
who does all these things. It's
Correct.
there
Yes,
would
yes.
be a separate environment team who used to
Exactly,
do.
exactly. You don't need to do these things, okay? This I just showed so that you get an idea how the cloud works, how the cloud looks, for example, if someone is very new to that.
Sir, for monitoring purpose only, that part will be handled by monitoring the team which is handling monitoring and
Correct. Yes. Monitoring team will be there already. So they will help you, the DevOps team and all. They will help you to set it up and all. Sometimes you might get to set up some tools. So that's why in this course we are going to learn how to set up Grafana, how to set up Prometheus, Grafana combination, how to set up AppD. That we will learn, okay, in this course, because sometimes that performance testers will get that responsibility also. Sometimes. Yeah, go ahead. Any other questions? I heard one more voice.
So Grafana, Kibana, Prometheus configuration could be done by performance tester over
AppD.
cloud.
Yeah, AppD also. Yes.
Okay. Okay. And if there are if there are multiple servers, so
Mm-hmm.
do we need to install on each server these things, or it's a kind of
Yeah, it's
configuration?
that is a little high jump. Yeah, you if I want to explain that, I have to explain a lot of other things. You will
Okay.
learn all those. okay, in the upcoming
Just
session.
quickly, or it's a kind
Not
of
on
agent.
all, based on the application. Because see, AppD also where you install matters a lot. For example, if it's a Kubernetes cluster, it's a different way. If it is on premise, it's a different way. The agent installation will change the method.
Agent.
Okay.
Yeah. Okay.
Hmm.
Agents are
So
there, na?
correct. Yes.
So we are actually installing agents, and that sends the logs to the main
True.
config.
Yes.
Yep.
But
Okay.
Grafana works different way. Not like AppD. There we
Okay.
have the Prometheus Grafana communication. Prometheus agent will run in
Hmm.
the servers. It will collect the data, feed the data to the Grafana.
Okay. Get it. Thank
Yeah.
you.
Yeah.
Hello, sir. I have
Yeah,
one doubt.
Manoj. Yeah.
Suppose this AWS, Azure, GCP are cloud technologies, right? As a
Hmm.
performance tester, you are preparing the script in tool and moving to AWS. How much is required? Full course is required, every pin to pin point like AWS, or how much level it required? AWS, GCP, Azure.
No, no. See, you don't need AWS at all. That's what I'm saying. See, JMeter script you will not move to AWS.
Mhm.
AWS I showed for monitoring. No, for example, you are a doctor. And you are testing heartbeat. Will it change the way you test heartbeat? Will it change based on the patient?
Based on the patient, no.
Uh, or better question is like um, the procedure, okay, which a doctor will take to examine the patient, a preliminary examination, will it be same?
Mm,
Means like the common things that they will check, will it be same?
General checkup is everybody same, right?
Yes, exactly. So that's what I'm trying to say. So JMeter thing will be same for everyone. So if
no.
you're in the range of 2 years, 3 years, 4 years experience range and all, you won't even reach the cloud. Maybe you will run the script. You will get the data directly from AppDynamics, Grafana, and all itself. You even might not know what is happening in the cloud. Okay, but this what I showed is for people who are beyond that, who need to get into that cloud and check the servers, right? What is happening in the server? Are you getting, Manoj?
Yeah, yes, sir.
So what is this AWS, Azure and all? In that your application is running. Okay, where is this Google in my system? Okay, where is this Google Chrome running in my system? Where is it running?
Locally laptop.
In my laptop, right? Same way, where is Amazon.com running? Amazon.com is running in server somewhere, right? In some cloud.
Yes.
Are you getting? Because Amazon.com is an application like Chrome. Are you getting, Manoj, Rohan?
Yes, yes, sir.
Yes.
Yeah. So that is what I'm showing. The Azure and AWS and all these things, these are for running my application, not running JMeter or not running performance test. Are you getting?
Yeah.
Yeah. Okay. So that we will see further. Okay, you will get a better clarity when we go deeper into JMeter. Okay, this is not related to JMeter. This is more about monitoring and analysis, where you are monitoring your application, right? How it is performing. When I'm running a performance test, how is the CPU utilization? How is the memory utilization? Now, if I have to see that, I have to get into the cloud. No, if I don't have any monitoring tool, are you getting? Now, if you don't know what is Azure or what is AWS, you might not be able to do that, right? So that you can imagine or you can come to a point where you know, okay, what this cloud really means. Okay, for that purpose only I showed Azure.
Okay, sir.
Or in a very simple manner, being a
Mhm.
performance tester, we are executing performance test. It is impacting servers, so someone has to look at onto the server that what is happening because of our load test. That's
Correct.
it. That's
Yes. Okay, yeah. So now let me close the cloud and on-premise very quickly. So that's how on-premise and cloud works. Okay, so based on various factors, you can optimize and choose whether my application has to be on on-premise or cloud. And but these things you don't do anyways because your application will already be deployed and all when it comes to performance testing. It's not that you do all these things, but you need to know these details, right? Whether your application is on premise or cloud, whether it's on which cloud, AWS, Azure, because that will you will be able to monitor and analyze. So it's more about, if a patient is coming to me, I need to know whether the patient is female, male, or whether the patient is a child, an adult, or so the characteristic of the patient will change based on these parameters, right? So that I need to know where my application characteristics I need to know. What server, what DB server, what web server, what CDN, what load balancer, whether on premise, whether on cloud, whether it is AWS, Azure, Google Cloud, what it is. So all these questions we need to ask before we start a performance test to the architect or the development team, so that we can properly monitor and understand. Clear, all of you?
Yep.
Okay, so that is why we are seeing all these things, because you can ask question about only those things which you know. Are you getting my point?
Yeah,
Now,
correct.
if you think there is something like cloud doesn't exist at all, will you ask like which cloud my application is on? No, right? So as a QA, you need to know the things that are there, but you don't need to know very deep how these things work also, but you need to know in a high level way what these things are, so that you can ask those right questions when you test, and you can also look into that those right places to find out what's the issue with your application or system. Clear, all of you? And that is the objective. We are seeing all these things. You won't be writing a code, or you won't be deploying an application onto the cloud and all, but to find out an issue, you need to know, okay, these things are there, these are the places I need to look into, and these are the things I need to do to look into those, right? So these things you need to know as a QA. Clear, all of you?
Yes, sir. Yes, sir.
Yeah. So whoever is clear till now, just raise your hands. I don't know whether Zoom has raising hands. Reactions, I don't know what is there. Maybe reactions, huh? Zoom doesn't have raising hands. Reactions only. Okay. So I can see. Vikas has raised hand. How? Vikas? Okay.
It is
There.
there now in reactions.
Oh, okay. Is it there? Okay. Nice. Yeah. So I can see most few are silent. What about Anil, Mahesh, Srinivas? Srinivas, how are you? Like, is it going well? You're understanding things?
Yes, 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 yes.
Okay. Good, Srinivas. And keep me posted. Okay. If you feel anything, any issues. Okay.
Sure, sure, definitely, definitely.
Yeah. Yeah. Karthik, Manoj, Ganga. Today Ganga is silent. What happened? Simal, Rohan, Rohan,
No,
yeah,
no, no.
Rohan.
I'm listening,
Okay,
Vikesh.
maybe for Ganga, these are some very simple topics. I don't have anything to discuss. Is it, Ganga?
Kind of, yeah. Kind of,
Okay,
yeah.
yeah, but people are looking forward to your valuable inputs. Okay.
See, definitely, I'll do that, Vishnu.
Yeah. Thank you. Then Anamika, Tirupati, Tirupati, yes. Deepak, what about Deepak? Okay, I hope all of you are getting things what I'm trying to convey. And it's just starting of the course. Don't no need to feel that, oh, I'm not understanding, or many things are few. It might be very easy, I know, but few it might be little overwhelming because you're just starting off with these things. But no need to worry at all. As we progress, it will become like just a piece of cake. Okay, it will be very easy for you all to learn, and I am there to help you all in every step. Okay, so don't need to worry at all. Even when
Hello?
you're working in your project or anywhere also, I'm always there to help you all out. So be in touch. Now, especially for example, let's say I called out Srinivas because he's in touch with me. He has shared his problems, so I know him. So that way, all of you can also get in touch with me if you face any issues in any chapter or any sections. So okay, so be in touch and
Question is
share your
how.
things. Yeah.
Question is how, Vishnu, I can get in touch with you.
No, I'm always putting good quick bites and all in WhatsApp. No, message me back.
Okay. Oh,
Oh,
okay.
do you feel that is done by the trainer? I mean, like team?
I thought
No,
it's a kind of AI activity.
no. That like I put good amount of efforts to find out some nice topics. Okay, so
Okay.
so that you all get the real gist of what's performance testing. Okay.
Yeah.
So yeah, that's why I keep putting. So do read it, okay? It's really interesting.
I actually read it. I
Okay,
actually
okay.
read all those things. Yeah.
Yeah, yeah.
You would have seen my reactions as well.
Yes. I saw. Yeah.
Yeah.
Thank you for that. Yeah.
Actually,
Okay.
this
Sir,
is my first class, sir. I'm not attending any of the class, so I
Okay.
was just getting things.
Sure. Yeah, no issues. Get in touch with me also if you face any issues, okay, in the recordings. Or actually, yesterday's recording we sadly couldn't recover because again due to Zoom and all. Maybe it's my fault also. I'm not that much used to Zooms. So maybe when it said that your session is getting recorded, I thought maybe it's getting recorded, but it wasn't. Today, hopefully, yeah, I can see that symbol at the top is getting recorded. So yeah, but yeah, go through the recording only yesterday's session that I will revisit in the upcoming sessions sometime. It's UI testing only. Again, I will revisit. Okay, for all.
So Vishnu, I can WhatsApp over the group as well as one to one if
Yeah,
I do.
one to one you can WhatsApp me.
Great.
But
Yeah.
but daily throttle limit is two.
No. I'm not going
Just
to put
kidding.
multiple
Yeah.
messages.
No, just
When-
kidding. Okay, you can
Yeah.
put how many ever you want. Just I'm
No.
kidding.
Yeah. Yeah.
Oh, maybe that throttle and all we didn't reach in performance yet, no? So maybe that's why that joke got
Didn't get
passed.
everyone.
Yeah. Okay.
Yeah.
Yeah. Okay. Anyways, so let's stop it here for today. Go through the recording again. Tomorrow also we'll continue on cloud and these architectural concepts and all because these are very critical for you as a QA to know. And even interviews also they start off with such questions and all. In what application you work, what was the app server, what was the web server you used, or how was it hosted on cloud, on premise, or well, if it's a load balancer, what the load balancer used to do, what issues you saw in load balancer. So these are some common questions, challenges that you get in the interviews, not just scripting, right? How to parameterize, how to correlate. These are like very old style questions nowadays. Okay, so these will help you all. Okay, very much. So stay tuned. More coming on the way. Okay.
Yeah,
Okay. Yeah.
nowadays no questions are coming from all cloud side. Okay,
Correct.
because of
Yes.
distribution systems. Okay, they
Yes.
may ask. Uh, Now even CV also is a common for developer and tester and performance tester. Everybody. Do you know Python? Do you know shell
Yeah.
scripting? Do you
Mm,
know cloud? Do you know like that?
yeah.
There are so many distribution
Mhm.
systems. Yeah,
Yeah. Yeah, but
common.
Yes.
yeah, the scripting and all, no, when they ask like this Python, C sharp and all, you can directly say, no, I haven't much worked on because nowadays, even interviewers also know that, see, sometimes HR will also put some random things, okay? They also don't know really. I have seen it, okay? Because what we give the JD and what comes really online will be totally different. So
Yeah.
that is totally fine. So, but you really should focus on what a real performance tester in that years of experience would have done. Okay, that is very important because that interviewer will already know, right? He's in that domain. He would have worked on it, so he knows. Okay, what is needed, what is not needed, what is just I mean, like just some additions which HR has added. Okay, so no need to worry about those things.
Vishnu,
But
on this track only, I really need to understand, does this Python and all, do we really need to know for
no,
performance
I
testing?
don't think so. If you're focusing on performance testing and performance engineering and all, no, Python is
Yeah.
not needed. Also, nowadays AI is directly giving code to you. Okay, like many companies are applying Cursor AI, Lovable, and all directly.
Uh-huh.
Okay,
They
so
are asking
code,
100. They are asking 100 scriptings. This you know this one, you know that one. What
so
nonsense?
you just say we use Cursor AI in our organization. So it used to generate or Windsurf or Lovable. It used to generate script and give it to us. Simple.
Cursor, Win AI, and
Actually, these are three leading ones. Cursor AI is used by Microsoft and such big organizations to code. Okay.
okay.
Similarly, Windsurf is there. Windsurf is again one AI tool which is used for coding
Mhm.
assistant. Okay. And similarly, there is Lovable. Lovable is also getting traction nowadays.
So, does these AI have any kind of interaction in performance testing?
You can generate bean shell scripts and all, maybe JavaScripts or some even wherever some scripting like coding is needed. No, you can use these tools. These are good in coding.
Okay.
See,
Yeah.
because majority of the times in the performance testing, no, you may need to generate the test data. During that
Mm.
time, you may need to have some couple of scripts. sometimes developer may provide. We may need to modify based on our custom
No,
need
that's
actually.
fine. That's fine. That's fine. But actually, I really wanted to understand. Actually, AI has any kind of intersection in performance testing as of now or not, because I am not
Not
aware
too
of
much, not too much,
Not
but
not
yeah,
too much, yeah.
yeah.
it.
So
Okay.
also there is a like a subscription, as Vishnu said, no, based on the subscription. If you go for the normal subscription, maybe $20 or $30, you will get some basic info. If you pay per month like $200, $300, you will get full rights. Okay, you ask human thing also, it will provide all the things.
So actually, Vishnu, my exact question is, can we do any AI trick or magic for
Hmm.
creating a JMeter script or a LoadRunner script or a NeoLoad script or not? As of
Okay.
now, till
So
today.
the thing is, correlation
So
parameterization and all is not that easy to be done in AI. That's frank. But JMeter script, a basic one, you can quickly get generated using har file. There is one technique for that. Using the har file, you can like what the AI will do is it will give you the JMeter script. But again, it is not efficient at all because the correlation, parameterization, and all those things are actually human
Manual.
instinct. It's not based on AI. For why I'm saying that is, for example, the script that you create and that I create might be totally different.
Mm-hmm.
Okay, that because my instincts and my experiences will be different, yours will be different. But ultimately, throughput, response time, these things will be same. Okay, that's SLA.
Correct.
But how
Yeah.
your script is operating, because maybe that same thing you can do in two different ways, right?
Correct. Yeah.
So those things AI cannot, because AI will have that standard format, no. So based on that customization, right, is not that easy to be done by AI.
For web application, I'm asking in terms of exact, very simple web application.
Yes, you can. You can. If it is just an API, it will give you a JMeter script directly.
AI will give the JMeter
Yeah,
script.
but that trick only I know.
Please let me know because I really need it badly.
No, surely, surely. I will.
I'll ping you one to one over
No,
WhatsApp.
I will show you all. Okay, I will show you all. It's not. It's a very a basic trick only, not very very difficult and all. But for APIs only, it will work. Again, a disclaimer. It will not work for an end-to-end application and all. Okay.
No, so API means only API calls or a web page has where the API has been deployed.
APIs, yes. Web page with APIs, yes. You can.
Web page with APIs. Vishnu,
Correct.
I
Yes.
need your help there.
Uh,
Thank you so much.
do proper scripting only. I will not help you in.
No, no, I will take it. I will do it proper scripting with the course. But I just want to showcase something to my client that I have
Yeah.
done some
Mm-hmm.
scripting actually.
Mm-hmm.
That's my
Yeah.
point is.
Sure, sure. Yeah.
Yeah.
Because this solution we developed for our organization.
Okay.
Uh, that's why I know a bit on that. But maybe more people will also know about it. Not that it's
Mhm.
a very, very
Very niche.
yes,
It's not niche.
not something very confidential and all.
Yeah.
But yeah, it
So
has some process to do. Yeah.
Okay.
so when are you going to start private classes, Vishnu?
Soon, Ganga. Like
Uh,
actually, anytime this sessions will end. This basically it gets extended due to some request which people
Okay.
ask.
Hmm.
So team will extend it, but it will soon end. Okay. I also don't know when it will end clearly,
Okay.
but
Hmm.
anytime. Maybe today might be the last day, or maybe tomorrow. So team
these
will
are
decide.
these are bonus.
Yeah, bonus, correct. Because some they are very much interested in learning, no? So they might they ask for few more extensions due to whatever reasons, right? So, and I also don't stop them because I love teaching. Anyways, I don't want to restrict anyone. So, but yeah, but we have to stop at one point also uh, because yeah, whatever reasons, right?
Yeah,
So
personally, I have good opinion, and few of my friends also recommended this class.
Sir, one doubt is, do we cover automatic script in JMeter?
no, no, no,
Do
no.
we use?
Automation scripting, we have this web driver, Selenium web driver,
No,
which
do
we
we
use
use
in
it in
JMeter.
JMeter
Mm.
for test for like state server UAT like that?
Yeah,
So
yeah. So
different.
basically, what happens now? It's not automation testing, I will say, but more sort of like a WebDriver. We have one Selenium WebDriver to test UI based application, heavy. For example, JavaScripts and all you cannot load in JMeter directly. You have to use that plugin, but it's not automation. Okay, nothing like automation.
Okay. Okay.
Yeah, it's again a performance testing only.
Mm.
Yeah,
Are we going
but
to cover any Fiddler and
yes,
BlazeMeter
yes, yeah.
also?
Fiddler we will cover, yes. When we because generally when I do mobile app testing, no,
Mhm.
Fiddler helps me a lot than JMeter. Okay, so that we will be seeing. Yes,
Great.
yeah.
Yeah, I have some dotted lines, Vishnu, like mobile application testing and
Hmm.
few of the monitoring areas.
Yeah,
But
yeah. Mm.
rest I can correlate. I'm eagerly waiting for those sessions
Yeah,
actually.
yeah, yeah, Ganga, yeah.
Yeah, soon we'll join. We'll
Sure,
start
sure.
that also.
Yes,
Yeah.
yes. Yeah, few basics will be there because it's a totally an end-to-end audience, no? So we need to cover basics also and also advanced concepts also. So some things you might feel basic, bear with me, but yeah, so slowly things will become better. Okay.
Yeah, yeah.
Yeah. Okay, right. So
sure.
then let's stop it here for today and we will meet tomorrow. Thank you all.
For sure.
Have a
Thank
good
you.
day. Thank
Bye.
you.
Thanks everyone. Thanks.
Thank
Bye.
you.